Good morning, students. Let's start second semester syllabus. I'm going to deal with your third unit, that is alternating current. In our pre-university courses like PU, we had learned about alternating current. In a AC generator, armature or a rectangular coil is made to move in a perpendicular or between the two poles of magnets. The reversing generating current is sinusoidal variation with current is called as alternating current. So now we are learning about alternating current. So let's move for the definition. So we can write alternating current as AC. Current which is periodically reversing its direction is called alternating current. Then continuously means continuously changing its value. Let's take a sinusoidal wave, that is I along y direction, time along x direction. So this is positive half cycle and this is negative half cycle. Then this is amplitude. Let's write this as plus I naught, and this is negative side waves amplitude. This is minus I naught. Okay, then this is the positive side and this is the negative side. See here, it is this wave or one cycle is continuously changing its direction along with time. As the time goes on increasing, it is the wave, the sine wave, or else one cycle or else signal is continuously changing its direction. Okay, then you may ask a question, does it takes place in only sine wave? No, we can write in cosine wave also. So how does it changes its value in cosine function is like this. So this is cosine function one cycle. So this is plus, this is positive side. Then in the second phase, so here decreasing with negative value, again increasing in negative value, again increasing in a positive value, again decreasing in positive value. This is second cycle. So we can take many cycles like this. Okay, then again here it is decreasing with negative cycle in increasing in negative cycle. Like this we can take, even we can extend this also. So this is a second pulse. So here its value is pi and this is 2 pi and this is 3 pi. Like that we can continue our signal. So only does it takes place in sine wave and cosine wave? No. Let's take we can write this in square wave form also. Square wave is like this. Okay, this is the first cycle pi. Let's write this is 2 pi. Okay, then this is square wave. Here this is plus, this is negative, this is positive and this is negative. Okay, then we can write this in triangular waveform also. So this is triangular waveform. This is one cycle here. So this is positive direction, this is negative direction. Even This is triangular wave form. This is a square waveform. This is okay. Then we can take this in sawtooth form also. Then how does it move, same direction. This is the suddenly decrease in, then increasing, suddenly decreasing, increasing, suddenly rapidly decreasing. Here also this is positive side, negative side, positive side, negative, so on, like this, the time along y-axis. So these all are the form of AC signal. We can take in sinusoidal form, okay, we can take in cosine form, we can take that signal in square form, we can take this in triangular form, we can take the wave formation in sawtooth form. Okay, let's discuss about this. Then let me draw a small diagram uh, like this. Could you say this is an AC, means is it a AC alternating current? No, it is not a alternating current. Okay, why? Because, so let's check about this amplitude. Amplitude is here I naught, then this is also negative I naught, this is plus I naught, and here amplitude is not same, it is decreased here. Okay, and again here this also, this amplitude is also decreased. The decreased amplitude is there, so that's why it is not AC, means alternating current. So this we can call it as a damped oscillatory function. Okay, but it is not AC, but it's not AC. Okay, let me draw one more diagram that is like this. Okay. Okay, so this is positive, 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 positive. So our T is here, then I is here. Okay, so do you call it as AC or else alternating current? No, we can't say this as alternating current. Why? Because the fluctuation is in only positive direction. So that's why it is not AC or else alternating current. Then one more diagram. So this is T, then this is I. Okay, the amplitude is same only. Here here also amplitude is same, but the direction is, it is in the positive direction, so that's why here also it is not a AC. So here amplitude is same, let's say it is constant. In this case we are not calling this as alternating current. This is not alternating current, but this is direct current. Even though we can calling this DC as constant steady current. Okay, then let me go for another diagram. This is the case where the amplitude is same. Okay, this is I naught, this is I, this is T. Okay, do we call this as alternating current? So here is I naught, this is I naught, this is I naught, means that amplitude is I naught. It is positive in positive cycle, this is also positive cycle, this is also positive cycle, there is no negative cycle. So this we can call it as pulsating DC. We are not going to call this as AC. We are going to call this as a pulsating DC. Then we can write some equations of these alternating current as I is equal to I naught sine of omega t plus pi, sorry, plus or minus pi. Okay, then do we write in only sine function? No, we can write this in cosine function also. That is I is equal to I naught cos of omega t plus or minus pi. So this is the equation. We have to remember this equation. Why? Because the whole chapter, it is based on this equation. If you remember this equation, it will be easy to solve problems as well as have to understand the further classes. Okay, now let's move for the average definition. So these all are basic. Okay, let's move for the average definition. How do you define average in alternating current? Okay, then average value, we can call this as average value. Okay, let me write AVG for average. Average value or mean. Commonly we are using this term mean. Okay, this is tell you about what it does, what it is tells about. It tells about the amount of charge is transferred in a given interval of time. ಈಗ ನೋಡ್ರಿ ಎಷ್ಟು ಚಾರ್ಜ್ ಗಿವನ್ ಟೈಮ್ ಒಳಗೆ ಆ ಸರ್ಕ್ಯೂಟ್ ಒಳಗೆ ಮೂವ್ ಆಯಿತು ಅನ್ನೋದು ಯಾವ್ದು ಹೇಳ್ತೈತಿ ಅಂದ್ರೆ ಎವರೇಜ್ ವ್ಯಾಲ್ಯೂ ಹೇಳ್ತೈತಿ. ಓಕೆ, ಕರೆಂಟ್ ಅಂದ್ರೆ ಏನ್ರಿ? ಕರೆಂಟ್ ಅಂದ್ರೆ ಇಟ್ ಈಸ್ ದ ಫ್ಲೋ ಆಫ್ ಚಾರ್ಜಸ್ ಅಂತ ಹೇಳ್ತೀವಿ, ಹೌದ್ರಿ? ದೆನ್ ಅದ್ರೊಳಗೆ ಏನಿರ್ತೈತಿ? ಡ್ರಿಫ್ಟ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರ್ತಾವೆ. ಸೊ ಅವಾಗ ನಾವು ಕರೆಂಟನ್ನು ಏನು ಬರಿತೀವಿ? MEAVD ಅಂತ ಬರಿತೀವಿ. ವಿ ಡಿ ಅಂದ್ರೆ ಏನು ರೀ? ಡ್ರಿಫ್ಟ್ ವೆಲಾಸಿಟಿ ಅಂತ ಬರಿತೀವಿ. ದೆನ್ ಅವರೇಜ್, ಈಗ ನಾವು ಏನು ಮಾಡತ್ತೀವಿ ಅಂದ್ರೆ ವಿ ಆರ್ ಡಿಸ್ಕಸಿಂಗ್ ಅಬೌಟ್ ದಿಸ್ average value. Then average value, how we are going to write average value? In current what happens? Electrons are oscillating. What does it do? The electrons are oscillating, so that's why we will get positive and negative directions. Along with oscillating with respect to time t. Okay, with respect to time t. So that's why we can write I average, or else average current is equals charges, average charges moved in a particular time t. You can take small t or else capital T also. This is the what we have learned in elementary classes. Okay, in a degree classes we can write in a integral form, that is I average, that equals q. How can we write q? Here we are taking a certain limit, integration of I into dt. Let's write q as I into dt. So this, let's take limit over 0 to t, small t, let's take. Then here 0 to t integral limit with dt, time t. Okay, then how can we write this? I is equal to, we know I is equal to I naught sine omega t, that we know. Okay, then how to evaluate? Let's move for the how to evaluate average value. Okay, for one complete cycle. For one complete cycle, that is 0 to t. Let's take 0 to t. Here I average, that equals integral over 0 to t. I is I naught sine omega t over integral over 0 to t into dt. So I naught is a constant. Here integration of dt is t, isn't it? Integration of t is dt. Then with the limit 0 to t. So let me write capital T. So I naught is a constant. Let's take outside from this integration. Then this integration, the value of this integral is capital T. So what remaining? 0 to t into sine omega t. I naught sine omega t. Only sine omega t. Let's calculate this equation, that is I naught by t is a constant. The integration of sine omega t is minus cos omega t by omega. Integral limits are 0 to t. Let's write this as I naught omega into the bracket, this I naught t omega. Omega is a constant. Let's take outside from this bracket. This is minus cos omega capital T plus cos 0. Upper limit minus lower limit. Then I naught omega t cos 0 is 1 minus, let's replace omega by 2 pi by t. Okay, then what it will becomes, so minus cos 2 pi by t into this t. Okay, t get cancelled. Okay, the remaining answer will be I naught omega t. So cos 2 pi is 0. So sorry, cos 2 pi is 1. 1 minus 1 is 0. 0 into anything is 0. So I average for the sinusoidal wave. Let me write here. For the I average, this is positive and this is negative. Okay, that we know. And this is I and this is I naught, that we know in this diagram. So I average current move in a circuit is 0. That it shows the sum of this positive values and this negative values. Sum of positive values and negative values will be 0. So that's why I average in this one cycle. For one cycle, average value for one cycle. So this is, keep it, remember, average value for one complete cycle is 0. Okay, let's discuss about half cycle. For one cycle it is 0. For half cycle, what is the value of I average? Let's learn in this next class. Okay, thank you. Then be careful, wear mask and wash your hands often. Okay, be safe, be at home. Okay, thank you, have a good day.